Good evening. For tonight's video, we will be learning about scale drawings. Our essential question is, how can you use scale drawings to solve problems? We have two new vocabulary terms. The first is a scale drawing, and it is a proportional, two-dimensional drawing of an object. And our second vocabulary term is scale, which is what we use in a scale drawing, and that is a ratio between two sets of measurements. It shows how a dimension in a scale drawing is related to the actual object. And scales are typically shown as two numbers separated by a colon, such as 1 to 20, or 1 centimeter to 1 meter, which means that 1 centimeter represents 1 meter. Scale drawings and scale models are often used in map making, so people that make maps, the construction trade, architects use this, and then there are a lot of other trades that use scale drawings and scale models as well. Our first example with scale drawings focuses on a blueprint. A blueprint is a technical drawing that usually displays architectural plans. Pete's blueprint shows a layout of a house. Every 4 inches in the blueprint represents 3 feet of the actual house. One of the walls in the blueprint is 24 inches long. What is the actual length of the wall? So we're referring to this wall right here in the blueprint, the 24-inch wall. And we can see that this scale drawing is a pretty good representation of an actual house, and we know that it is obviously drawn to scale. So our first step is to figure out what 1 inch means. So using the scale that we have, we know that 4 inches represents 3 feet. And so I'm writing this as a ratio, which is the fraction format, and I'm going to use a proportion to figure out how many inches, or how many feet, 1 inch represents. So looking at this is what I want to know. How many feet? That's that x. X is how many feet does 1 inch represent. So when I look at this, I can tell that 4 divided by 4 is 1. So I need to do the same thing to 3. So 3 divided by 4 equals 3/4, or 0.75. And the measurement, or the units, is in feet. So 0.75 feet, or 3/4 of a foot, equals 1 inch in this blueprint. Using this scale, and I'm going to actually modify my scale here and use a semicolon there. So we know that 0.75, or 3/4 of a foot, are equal to 1 inch in the blueprint. Now going on to step 2, which is where we actually figure out how many feet 24 inches represent, I can use this scale here. So I know that 1 inch represents 3/4 of a foot. So setting up my proportion, and notice how my measurements, my units, are aligned. I've got inches on top. So 24 inches, and I want to figure out how many feet that is. So I can tell here, well, from 1 to 24, I multiply that by 24, and I need to do the same thing with 0.75, multiply that by 24, and I get 18. Now there is also a second way of doing this, and is still using that proportional setup, where this time we're just using simply the scale that is already given to us and just that scale alone. And so now if we were to go back and do the exact same thing using that scale, we would have it set up like this, 4 inches are equal to 3 feet of the actual house, and then setting that up again, 24 inches in the blueprint, and we want to figure out how many feet that is equal to. And so now looking at this proportion, I can visually tell, like we've talked about in class, that the relationship between 4 and 24 is multiplying it by 6. So I would do the same thing with my actual measurement in feet, and 3 times 6 is 18. So the actual length of this wall in the actual house is 18 feet. What I'd like you to try now is this problem right here real quick. I'd like you to use either one of the scales, either the scale that is given to you where 4 inches equal 3 feet, or the scale where we determined what 1 inch represents. And remember to set up your proportion. Alright, so the back wall of the actual house is 33 feet long. What is the length of the back wall in the blueprint? So that's this wall right here. So setting up our proportion, I am going to use the original scale given to us in this problem, that 4 inches equal 3 feet. And so now the information that I'm given is in feet. So that actually goes on the bottom, because that is where my measurement or my unit feet is at in my scale. So I'm being consistent. I've got feet on the bottom here and feet on the bottom here. So 4 inches is equal to 3 feet, and I want to know how many inches is equal to 33 feet. So when I look at the relationship between 3 and 33, I can tell that I just multiply that times 11 to get 33. So I must do the same thing to what's on the top. And 4 times 11 is 44. And what I found was not feet, but inches. So in the blueprint, this back wall is 44 inches, and it represents 33 feet in real life. Now for example 2. The art class is planning to paint a mural on an outside wall. This figure is a scale drawing of the wall. What is the area of the actual wall? So now not only are we going to figure out actual dimensions, but we're going to take it a step further and calculate the area. So just like our last example, the first step is to figure out what 1 inch represents. And we have to start by looking at the scale that is given. And that states that 2 inches represent 3 feet. So I'm going to write that as a ratio. 2 inches equal 3 feet. And when I see here, when I set up my proportion, I want to know what 1 inch represents. So I can see that I'm going from 2 inches to 1 inch, so that's just dividing by 2. So I'm going to do the same thing with 3 feet. And 3 divided by 2, so half of 3, is 1.5 feet. So 1 inch in this drawing represents 1.5 feet in real life. So this is our important piece of information for moving on to step 2. So now we're going to find the actual height of the wall that is 11 inches. So that is this wall right here along the right side. So setting up our proportion again, 1 inch represents 1.5 feet in real life, and that is equal to how many feet in real life on the 11-inch drawing. So from 1 to 11, I multiply by 11, and what I do to the top, I do to the bottom, and 11 times 1.5 is 16.5 feet. So the actual dimension of the 11-inch wall in the drawing is 16.5 feet. So now, knowing that our whole goal is to calculate the area, we need to have both dimensions. So now I need to figure out how long this 28-inch wall is. All right, so setting up our proportion using the same scale. Oops. We have 1 inch again, representing 1.5 feet of the actual wall. And again, I want to know how many feet 28 inches represent. And again, take note of how consistent I am, where I've got inches and inches both in the numerator position. We've got to be consistent, otherwise we notice that we're finding incorrect dimensions. So I can tell that from 1 to 28, I multiply by 28, and I therefore do the same thing along the bottom. Oops. It's supposed to be a 28, sorry there. And when I multiply 28 times 1.5, I get 42 feet. So the 28-inch wall in the drawing is 42 feet in real life. So these two dimensions are what we need for calculating the area. And we know that the formula for area of a rectangle is base times height, or length times width, and we have both of those dimensions, so we just multiply 16.5 times 42, which gives me 693 feet squared, because we calculated the area. So the area of the actual wall, or the mural on the wall, is 693 feet squared. Now what I'd like you to do is try the two problems for the your turn on your own. As always, refer to the two examples and mark down any questions that you have, and we will discuss them tomorrow in class.